And the first speaker of the day probably doesn't need much of an introduction. Jan Cui is known by many as Jan, the serverless man, and he has been one of the biggest names in the serverless scene for many years now. He is a consultant and an AWS serverless hero. I am now bringing Jan to stage. Where are you, Jan? There we go. Hey, Jan.
Hey, everyone. Hello.
Thank you very much for joining us. It's an honor.
Thanks for having me. It's great to be here.
Hey, Jan, so can you tell us a couple of words about the course that people can win in today's raffle?
Yeah, sure. It's the AppSync Masterclass. It's a course that I've been working on for more than a year now. Essentially, you'll learn how to use AppSync and Lambda and DynamoDB. Essentially, build an entirely serverless backend for a Twitter clone. And there's also going to be a friend of mine, Gerard Sanz, who's going to be teaching you how to build it.
I know Gerard. Yes, I know him from other areas. Yes,
he's my co-conspirator. He does all the front-end lessons in the AppSync Masterclass and shows you how to build a clone of the Twitter front-end using Vue.js as well as using Tailwind CSS. So I've been learning a lot from him as well in terms of how to do front-end projects properly. So yeah, hopefully this course would give you a lot of ideas in terms of how do you build a full stack application. It covers everything you need to know about AppSync in terms of the basic GraphQL schema, subscriptions, how to do security, and how to do caching, observabilities, and all of that good stuff. So yeah, it's a quite comprehensive course. We have maybe 40 hours of content in total, and it's taken us a really long time to put together. So I really hope that you enjoy it.
Amazing. So folks, once again, you can win this course in our raffle, and I will share the link to the raffle in the YouTube chat very soon. So Jan, are you ready to share your screen?
Yeah, absolutely. Just give me 1 sec and I'll share my screen. Okay, so let's see. Okay, yeah, we can see the screen.
We got it.
And there we go. Yeah, so today I'm going to talk about some of the lessons I've learned from running AppSync in production.
Okay, so I'm gonna make myself scarce and give you the stage here, Jan. Bye-bye.
Cool,
I'll see you in a moment.
Yeah, so my name's Jan. I've been working with AWS for more than 10 years now. I guess my first project running stuff on AWS was back in 2009. And nowadays I'm an AWS serverless hero, and I also work with Lumigo as a developer advocate. And Lumigo is probably I think hands down the best observability tool for serverless applications. And the other half of my time I work as an independent consultant, where I help other companies adopt serverless, and sometimes that means advice, sometimes it's training, sometimes I go ahead and deliver a project for the client. And in my capacity as a consultant, I worked on 3 separate projects in production with AppSync in the last 18 months. So it spans across multiple sectors, including social network, a healthcare app, as well as a document assembly app. All had some interesting business sort of angle and multi-tenancy requirements. And all 3 projects are pretty big, as you can tell from the number of resolvers involved in those AppSync APIs. And the stack for these projects pretty much consists of AppSync, Lambda, and DynamoDB. And I've used Cognito and Auth0 for authentication. And for search, Algolia is my preferred choice. But for the healthcare app, because of HIPAA requirements, we actually ended up going with Elasticsearch instead. And all 3 projects, I use Lumigo to help me debug and troubleshoot the application really quickly. And here are some of the lessons I've picked up, which I think has been really important in helping me getting things running in production reliably. I think the first and arguably the most important lesson is that you should be using Lambda resolvers as the last resort, because AppSync lets you write resolvers that reads and writes data from data sources like DynamoDB using VTL templates, where you can say what operation you want to do and the parameters you want to use. I know VTL is not the most easy to use programming language, but honestly, I don't think you have to write a lot of VTL code anyway. Most of the time, you're just writing a JSON blob that describes the DynamoDB operation that you actually want to do. Of course, sometimes you do need a bit more help. You do need a bit more control, so you can stick a Lambda function in there and you can use that to implement more complex business logic. You can use it to call third-party APIs with their own SDKs. And maybe you want to just leverage the built-in retries you get, as well as the exponential backoff you get with the AWS SDK when you use it to call other AWS services, so that you can make your application more resilient to temporary issues, latency issues from those other AWS services. Or maybe you want to implement some kind of a circuit breakers or fallbacks in case there are problems with, say, DynamoDB, and you want to fall back to some other services that you may want to use, or fall back to some static data that you can return instead. And sometimes you may want to just do more than one thing, like getting an item from the database and then update it and then save the changes back to the database. So those are multiple steps you have to do that you can easily capture in the Lambda function. You can, of course, also do that using pipeline functions, but we can talk more about that later, especially if you've got questions around how does pipeline functions work and some of the tips I have for working with them. Now, adding a Lambda function also adds another source for latency for your resolvers, especially when you consider the fact that you are going to see cold starts from sometimes. Even if the traffic in production usually keeps your functions warm, so that it's not nearly as bad as some people might suggest. But when you have nested resolvers, those Lambda cold starts can actually stack up. And that's where I find the things can get a bit ugly, where you have the first resolver calling Lambda, you get a cold start, and then you got nested resolvers calling other Lambda functions, and you see more cold starts, and they start to stack up. And that's where you're going to get really bad latency instead. It's also another thing that you have to pay for both the Lambda requests as well as the amount of time that your functions run for. And you have to worry about regional concurrency limits, which applies to all the functions running in the region, including functions that are not part of your AppSync API. So I think for these reasons, for simple CRUD operations, you just shouldn't use Lambda resolvers at all. And instead, you should go straight to DynamoDB from AppSync using VTL templates. Because it's going to end up cheaper, it's going to be faster, it's going to be more scalable. And I think it's also just simpler as well when you don't have to write and configure a Lambda functions for every resolver and all the things that comes with having a Lambda functions, including setting up IAM roles and so on and so forth. Quite a few people, though, have told me that they don't like this approach because they end up writing a lot of VTL code, and the VTL is not their favorite language. And I think this kind of stumped me a little bit when I first heard it, because it's the opposite of my experience. Even though I use VTL templates a lot, I don't actually end up writing a lot of VTL code. And it turns out that pretty much everyone I spoke to who complained about the amount of VTL code they have to write, they were using single table designs with DynamoDB, which brings me to my second lesson, that you really don't need to use single table designs. In fact, I think when it comes to using with AppSync, it's preferred not to use it. And let me explain. And in case you haven't heard about single table design, it's basically a collection of practices and modeling techniques that solve the problem of joining data when you use DynamoDB by pre-joining the data into collections in a single table. So imagine if you had, say, a users table and an orders table, and you want to build a UI page that shows the user profile alongside the user's orders. So you have to make a get item request to the users table to get a user, and then you have to make a query request to the orders table to get the orders that belong to this user. So that's two separate DynamoDB requests. Whereas if we have put both users and orders into one table, and then use some clever schema to squeeze the user IDs and the order IDs into these opaque primary and the sort keys, then you can use one DynamoDB query to get both the user and the orders by looking for the primary key of user number one. And you look for the sort key, which is either user or it starts with order hash. And in this case, you'll be able to get both the user and his orders in one request. And then you have to, of course, split the result in your code so that you get the user and then the orders. Which, if you think about it, it's actually pretty clever, right? And there are lots of other patterns that can help you model one-to-many or even many-to-many relationships inside a single table. But the fact that it's clever also means that there's a lot of there's a bit of a learning curve to it, especially for people who are new to DynamoDB. And I think it's, generally speaking, not good for greenfield projects, because once you've modeled all of these access patterns into your schema, you've created all of these indexes, it's not easy to change those access patterns. And it can actually be quite difficult to add new ones later on as well, as you discover and evolve the application. You're learning, okay, the access pattern we thought we're going to have actually turned out not to be the case, or we're going to need new ones. And the way, if you have one table for each entity, you can also use cost tags to track the cost for individual tables and monitor the usage cost by entity. You can't do that with single table design, because all the data access is coming and going to one table. And the funny thing is, the issue of joining data is basically a non-issue with GraphQL and AppSync, because the user and the orders can be handled by two separate resolvers. Each one's going to fetch data from different table, and AppSync is going to join the data for you for the response. So you don't actually have to do very much yourself. I mean, AppSync is kind of just solving, and GraphQL is kind of just solving the data joining problem for you. That being said, I do think you should learn about single table design and understand the modeling techniques so that you can use them where they actually make sense. I just don't think you should go around making a region out of it and literally put all of your data into a single table, because it's just going to make your life more difficult than it really needs to be. And when you use single table designs with AppSync, you do end up writing a lot more custom VTL code in order to construct those funky primary key and sort keys. And also you have to split the result, the data in the response the response template, to get the user and the orders data separately, and then combine them together again in the response in the VTL response template. Advocates for single table design might also say, well, but what about the cost savings you're going to have? Fetching multiple entities with one query is going to be cheaper than multiple individual get item requests. While that is absolutely true, however, those cost savings only going to amount to anything that's even worth thinking about when you're running at scale. For Amazon, apps and so even the out there, the cost of engineering time that's involved with using single table designs and all the extra complexities is going to far outweigh the DynamoDB savings that you're going to get by orders of magnitude. Besides, if you're really concerned about cost, then I think caching is a much better strategy to save on DynamoDB cost. So in one of our projects that I worked on that went to production, we managed to achieve an average of 99% cache hit rate. And at the end of the first month, when we went live and we got like over 25,000 monthly active users, our DynamoDB cost was really, really low. And most of the requests was being handled by the cache, which has another good side effect in that caching makes the API fast. Our 99 percentile latency was well below 20 milliseconds. So the customer was really happy, the fact that you got this API that's fast and the running cost was very low. So speaking about caching, AppSync supports caching out of box, and you can choose between having full request caching or per resolver caching. And I think the lesson here is that you should pretty much always go with per resolver caching, because the full request caching is just not very efficient at all. So if you take this GraphQL request to fetch your timeline from, say, a Twitter clone, like the one you built if you were to take my AppSync masterclass, with full request caching, AppSync is going to cache the response against this entire request, and it's going to use the arguments as well as the identity of the caller as the cache key. And this is not going to get you very far, because in the example here, a user's profile can appear in many, many tweets and show up in many users' timelines. And even though this user's profile probably hasn't changed for a long time, we're still going to fetch it from the database many times, once per caller, per unique request, based on the arguments, which is in this case a limit of 10 and the next token of no. And similarly, this tweet that's going to show up in my timeline is going to show up in many users' timelines, but each user is going to fetch data from the database, which, think about it, it's just going to be really inefficient. You're just going to keep getting the same data from the database over and over. Whereas with per resolver caching, we can enable caching for individual resolvers. It could be at the top level, it could be one of the nested resolvers. So in this case, once I've got a tweet, I've got a nested resolver to hydrate the profile for the creator of the tweet. And I can enable caching for the individual resolvers that gets invoked along the way. And I can also choose a different time to live value for each of those resolvers as well. So in this case, I can choose to use the profile ID for the profile as the cache key. And so that after the first user has fetched this profile as part of a request to get his timeline, any other user would get the profile from the cache until the TTL value expires, which is going to be far more efficient from a caching perspective. And this is the sort of thing that's going to help you get a really high cache hit rate in terms of your overall caching strategy. In general, you want to cache data that doesn't change very often, and you want to cache them for everybody. And doing this is going to be a big part of a good cache strategy. One thing to keep in mind, though, is that even though it's possible to flush the AppSync cache, if you want to clear the whole cache, then there is a control plane API you can call to just clear the entire cache. But if you want to flush individual items in the cache, you will have to do it via a VTL resolver. Now, the use case for this is, say, if you want to delete a previously cached response during a mutation operation. But if you need to, say, delete some cache response from, say, like a background process, then you have to add mutations to your GraphQL schema just for that, and make sure that it's only accessible by the background process by, say, using Amazon's IAM authorization method for this mutation. And when you have caching enabled, every virtual machine in the AppSync fleet for your API is going to open and maintain a persistent connection to some underlying Redis node. And creating this connection pool has a latency overhead, which you're going to see from time to time. And in my experience, it's going to add about 1 to 2 seconds to the request latency. Now, this happens very infrequently, but it happens at least once per virtual machine inside the AppSync fleet that is serving your API. And if you have X-ray enabled, then you can see this time in the X-ray traces. Unfortunately, though, this time to initialize the cache pool, the connection pool for Redis is not labeled in X-ray. So all you see is the big gap of time where nothing is happening. At least it looks like nothing is happening. But under the hood, the AppSync virtual machines are going to Redis and creating a connection pool. So moving on to lesson number 4. You definitely don't want to leave the field resolver log level setting to all when you go to production, because it's going to get really expensive really quickly. If you go to the logging section on your AppSync settings page, you can set the field resolver log level between none, error, and all. The problem is that these choices are basically having close to nothing, or having nothing, close to nothing, or having logging down to 11, because when you set it to all, you're going to get a lot of logs, including the input and output for every resolver and how much time the resolver took, as well as the context, the value that was used for each resolver execution, which is great for debugging. You can find all kinds of problems this way. However, it's also going to get really expensive really quickly, because all of these logs are going to CloudWatch logs and it's being charged at the 50 cents per gigabyte for ingestion alone. And if you're going to keep them around for a little bit, then there's also a 3 cents per gigabyte cost per month per gigabyte for storage. So you definitely don't want to leave the field resolver log level setting to all when you go to production, because the cost of those logs in CloudWatch can be prohibitive. But if you're like me and you want to have the cake and eat it too, then check out this blog post I wrote a while back, which explains the workaround that I used, where I use a pair of cron jobs to change the resolver log level between error and all, so that I get about maybe 3 minutes worth of detailed logs for every hour. It's not a great workaround, honestly, but it's the best one I can think of. where I can still get some benefit of those detail logs without overwhelming, having an overwhelming amount of logs in CloudWatch and create a cost problem for my application. And going on to lesson number 5 is that you need to have a way to handle user errors more gracefully if you don't want them to trip your Lambda alerts constantly and get woken up in the middle of the night because of that. So with HTTP, you've got HTTP 400 status codes that represent the user errors, and you've got 500 codes that represent system errors. If our system is not working, we definitely want to be alerted so we can fix them quickly. On the other hand, if users are making mistakes and sending bad data to our API, then it's something that we want to keep an eye on, because maybe our UX is not great and it's making our users do silly things. But it's not something that we need to deal with urgently. And it's definitely not something that I want to be woken up in the middle of the night because some users in the US is using my application and sending invalid or wrong data. When you're building REST APIs with API Gateway and Lambda, you can do your validation and then return 400 errors as a response. So the Lambda invocation was successful, but it lets us tell API Gateway to respond to the caller with a 400 error or 400 status code. With AppSync, however, there's no way for us to tell AppSync to return a 400 error from a Lambda resolver. If we detected that there's some user error, all we can do is to throw an error from the Lambda function, which AppSync is going to capture and it's going to include the error message in the response, which is great. The problem is that it also fails the Lambda invocation, which is going to trigger any alerts that we have on Lambda invocation errors. And what you can do instead is to return a payload from your Lambda function that captures the error information where it's applicable, and then use a custom VTL response template with your Lambda invocation, or with your Lambda resolver, to check if the Lambda response includes an error object. And if so, you can throw an error in the VTL response template instead. That way, the Lambda invocation is fine, is successful, but we're still able to fail the resolver with an error. So moving on to lesson number 6, you need to have a plan for the 500 resources limit in the CloudFormation stack, because an AppSync API has a lot of resources. You've got resolvers, you've got data sources, you've got IAM roles, and for Lambda resolvers, you also have the Lambda functions. Each one of them is going to have its own IAM role, hopefully, so that you can tailor the permissions for the individual functions. And it's going to have its own CloudWatch log groups and all that. So you're going to hit that 500 resource limit at some point, probably a lot sooner than you hope. Luckily, there's a solution for this, which is to use nested stacks. Each nested stack can have up to 500 resources, so that can significantly raise the ceiling for how many resources you can have in a project. And if you're using the serverless framework, there's a really handy plugin called the serverless plugin split stacks, which you can use. And the nice thing about this plugin is that you don't need to change your project structure. The plugin is going to move resources into nested stacks and update the references so that all of your ref and get attribute references will still work as if everything was in the same stack. But you need to make sure that you need to take care and make sure that you don't have circular references between the root and the nested stacks. This plugin allows you to write a custom script to decide where each resource will go, so you can use the custom script to split the resources in a way that doesn't create those circular references. And in my current project, I was able to split my pre-gigantic stack into over 50 nested stacks, and the individual stacks still doesn't have that many resources, so it still leaves plenty of room for me to grow this project going forward. And the last lesson is about how do you then go about modeling multi-tenancy with Cognito, because this seems to be a really common requirement, and a lot of the apps seem to have this kind of requirement, especially if you're building any sort of like business-to-business application. This is going to be really relevant for you. So where you need to model for like multi-tenancy, you need to model having tenants and users belong to a tenant, and each user has one or more roles, which limits them to some subset of the actions that your API supports. Not every single sort of multi-tenancy situation works like this, but this is a really common and recurring, I guess, pattern I'm seeing. So the simplest way to model this with Cognito user pool with AppSync is to use the user groups to model the different roles you have, and then to capture the tenant ID as a custom attribute, so that in your GraphQL schema, you can limit access to specific actions to some subset of the roles by adding this decorator to your GraphQL schema. And that's it. You're pretty much done. AppSync is going to handle the rest. So in this case, only the users that belong to either the admin or the super user group will be able to call this add user mutation. And to stop user from being able to somehow gain access to other tenants' data, you should also never accept tenant ID as an argument in your GraphQL schema. Instead, you always want to take the tenant ID from the context of identity object, which is the identity of the user or the caller, which has been resolved and verified by Cognito. So nowhere would you take a tenant ID as an argument for GraphQL operation and allow users to access tenant ID that maybe they don't own and trust a user to give you their own tenant ID. So it's always coming from the user's resolved and verified identity. So as a summary, here are the 7 lessons we've covered today. Number 1, probably the most important one, is you want to prefer use VTL templates over using Lambda functions. And you don't need to use single table designs with DynamDB when you're doing stuff with AppSync. In fact, I would say you shouldn't use a single table design when you're working with AppSync and DynamDB. And in terms of caching, always use per resolver caching, because the full request caching just not very useful at all. And when you go to production, make sure that you change the field resolver log level so that it's not set to all. And in production, you also want to handle user errors gracefully so that they don't trip your Lambda error alerts and then wake you up because users are sending you bad data. And you also want to plan ahead and think about what you would do when you eventually hit that 500 resources limit with CloudFormation, and where you need to model multi-tenancy. Then with Cognito, then you want to use user groups to model the roles and then capture the tenant ID as a custom attribute. And that brings me to the end of this talk. I want to thank you guys for being with us this evening. And as I mentioned earlier, I spend most of my time as an independent consultant. So if you want to see how servers can help you go faster or want to get some help upskilling your team, then let me know and go to theburningmonk.com to see how we can work together. So we're going to ruffle out a copy of my AppSync masterclass. So if the lucky winner, let me know afterwards. I guess maybe Natalia will let me know afterwards. And if you want to just check it out, go to appsyncmasterclass.com. So again, thank you very much. I hope you enjoy the rest of the event.
Jan, thank you very much. Enough of screen sharing now. Let's take that down. There, beautiful. Thank you very much for that wonderful slides as well. Very insightful.
Thank you.
Are you ready to take some questions?
Yeah, absolutely.
So, we have a question from Jones. For complex resolvers, what is recommended, VTL pipelines or Lambda FNS?
Yeah, so for complex workflows, you can use either pipeline functions or you can use just write a Lambda function. I think in most cases, it's just easier to write a Lambda function, except for case, I think where pipeline resolvers is really powerful is very useful is in implementing cross-cutting concerns. So one example could be, let's see, I had one of the applications I had, we had a really complex, a more complex multi-tenancy scenario where user can belong to multiple organizations or tenants, and depending on there's like a hierarchy of the organization. You've got parents and child, and depending on which for the same user, they may have different roles at different organizations, at different points of the organization hierarchy. So the sort of permission set is really complex. We couldn't just use a community user group to implement that. So to do a lot of validation, we use pipeline resolvers so that every action, every GraphQL request have to run this pipeline resolver, which then triggers another Lambda function to then run a bunch of more sort of complex validation to make sure that you are actually allowed to do this particular action against this particular data based on your role in your roles inside the organization hierarchy. And Another example would be, so for one of the healthcare apps I built, because it falls under the US HIPAA requirements, which requires you to have audit logs for every request and response, so that you know what data has been accessed and by whom and when. So there's no way to do that with AppSync out of the box. So instead, we wrote a little pipeline resolver to output every all the entire response to somewhere, so we can capture that and save them in S3, so that we can then use that later if we need to go through an audit process. And the trick with the pipeline resolver is that when you use them for cross-cutting concerns, you end up having to sort of insert them into your every single resolver, which when you've got hundreds of resolvers, it can be just a lot of manual work. So what I ended up doing was we wrote a little serverless framework plugin that inspects the CloudFormation stack, and then rewrites it to turn every single resolver into a pipeline resolver if it wasn't already, and then inject the resolvers that we want to do, say, in the before or the after of the main resolver that we have in there already. So in terms of just having more like one resolver that you want to do some more complex things, I think in most cases, I would go for a Lambda function, because it's just easier to manage and maintain.
Right. Also, Robert had a question. Jan, have you met with some limitations when using AppSync and resolvers? How do you ensure that resolvers using VTL are working properly? I'm thinking about testing them.
Yeah, so with AppSync, there's a couple of limitations. I think one of the big one for a lot of the large organizations is that there's no, so with GraphQL, well, maybe not GraphQL, but with, I guess, the Prisma guys can probably tell you later, with some of the GraphQL implementations, you have custom spec that support things like a schema stitching or some kind of mechanism that allows you to split one GraphQL API into multiple APIs. AppSync doesn't support that, which makes it pretty much that when you want to have one API entry point, then you have to have one AppSync API that sits behind the GraphQL schema. So that means when you want to separate them into different teams on a different part of that graph, it becomes more difficult. So that's probably the biggest problem, limitation right now. The way people work around it right now is just having multiple GraphQL APIs if they need to, and then the front end will use the multiple GraphQL APIs in that case. In terms of second part of your question, how do you test the VTL templates? So one of the things I show in my AppSync masterclass is how to write unit tests using some of the open source libraries that the Amplify team publishes, which allows you to essentially run a simulation against your VTL template, so that you can check, okay, based on this context object I'm supplying, and this template I've got, VTL template I've got, what does it translate the template into, so that I can check after when that once done, that is add. So for example, if I'm constructing, I'm doing single table design, I'm constructing this funky primary key and sort keys. I can then check with the unit test that transformation happens correctly.
Very insightful. There's another question from Tim. Have you ever encountered a situation where AWS Cognito was not good enough?
Yeah, quite a few times now, actually. Cognito is great in that it's got this nice integration with AWS services like AppSync and API Gateway, but it's also quite, well, it's definitely not developer friendly. Its documentation has got really bad, but quite a few cases, things like MFA doesn't do out of the box, and a few other things like that, which has kind of pushed me towards Auth0 instead, which is quite a bit more expensive than Cognito. The main thing about Cognito that makes it really good are the integration that you get out of the box and the fact that it's really cheap. For things like Auth0 and other things like that, you probably end up paying a lot more money compared to Cognito.
All right. Jones has another question. Maybe we can take that one short so that we don't run out of time. Yes. Best way to test and debug VTL resolvers. Any hacks or tips?
I think so. I tend to write a lot of end-to-end tests for my GraphQL APIs. For VTL templates, if the VTL template itself is just like a JSON blob to say do a DynDB get, I don't tend to write any unit tests for them because I don't think there's a lot of return on investment on those. But where I'm doing more detailed, more data transformation type of things, business logic in the VTL template, then I'll write unit tests using the approach I mentioned. Whereas for the other sort of VTL other sort of resolvers for Lambda, so anything I'm doing with Lambda, Lumingo gives me a lot of visibility in terms of what's actually going on inside the function. But the other VTL templates that I'm doing, I tend to write a lot of end-to-end tests for them instead of a unit test. So I will write a scenario where user logs in, go to my timeline, and then write a new tweet, and then he's able to then fetch his new tweet back from his timeline page, that sort of thing.
Thank you for that. What else is happening in the chat? So Paul has some very kind words about your course. Also,
Thank you.
evening,
Thank you.
I only recommend checking out Jan's course. Incredibly detailed, fantastic value. I'm learning a lot. So very kind words from Paul. Tal is saying good vibes back to you, Tal. I think that's supposed to be an emoji. No, that's just not loading. Anyway, good vibes to you. And yeah, everybody's being very polite, thanking you for your talk and your answers. And I think with that, I can let you go, Jan. Thanks a lot for your wonderful contribution, and I'm hoping to see you again soon.
Likewise.
Bye-bye.
Okay, bye-bye.